Okay, so this is a quick review of what we learned on day 1 and day 2. So this is a 60, so we know this is going to be 30 degrees. Come on. Okay, so this is a 30, 60, 90, which is a special right triangle. So I know this is the short leg, this is the long leg, and this is the hypotenuse. And so I know the hypotenuse is 2a, I know the short leg is a, and I know the long leg is a times the square root of 3. So now I'm just going to fill in what I know. I know a equals 7, so that means m is going to equal 2 times a, which is 2 times 7, which is 14. And I know n is going to equal a times the square root of 3, which is going to equal 7 times the square root of 3. In the second situation, I don't have an altitude label, so I know I'm going to use H, L, L, S. So I'm going to look at the big triangle first, label this H, this is my leg, and remember this is my side, all right? Just like over here, I can label this a side, and I can label this a side, and this is my A for altitude. So this one I'm going to use S, A, S. Okay, so I'm going to put H, X over L. I'm going to repeat L and put it over S. So I get 9x equals 15 times 15 is 225, and x is going to equal 25, because 225 divided by 9 is 25. Over here, I'm going to do S over A equals A over S. So I'm going to start with my side, which is 36, over my altitude, which is 48, and I'm going to equal it to 48. I'm going to repeat and put it over x. So this is 36x, and I do have to grab a calculator really quickly to figure out what 48 times 48 is, which is 2,304. Divide that by 36, and x equals 64. Okay, so let's learn something new. Today you should have a piece of graph paper, and this is lesson 34. Okay, and what we're going to be doing is learning our trig ratios. So to be successful with this, you have to know how to set up your trig ratios first. All right, so that's what this little discovery activity is. You should have your graph paper out, and you should be graphing 3 triangles that look very similar to these over here. This is GHI, this is DEF, and this is ABC. Okay, so you should have, and I did mine 3 different colors. And I went ahead and labeled my angles, and you'll see that angle A corresponds to angle D, which corresponds to angle G. And the right angles are B, E, and H, and they all correspond as well. All right, so once you've done that, we're now going to look at our angle measures. So, like I said, angle A, D, and G, they all correspond with each other, and I measured them with a protractor, and I got 55 degrees. Okay. B, E, and H, those were all the 90-degree angles. And so that leaves me with C, F, and I, and I just went ahead and did 55 plus 90, subtracted it from 180, and I got 35 degrees. Now I know that all of these triangles are similar, and I've got some choices. I could use the side, side, side similarity theorem, side, angle, side similarities, or I could use the angle, angle similarity theorem. The easiest one for me is because I'm comparing 3 triangles. I'm going to use angle, 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 because I can see that at least 2 angles are congruent in both of the triangles, which is going to make them all similar. If I use side, 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 or side, angle, side, I would have to set up a proportion for each one. So the easiest one for me is just to use A. Okay, so now we've got to build some new vocabulary words. So we're going to look at this diagram, and the first thing whenever you're doing trig is that it's always going to be a right angle. So the first thing you always want to identify is your hypotenuse. Your hypotenuse, it doesn't matter how your triangle is drawn, right? It can be drawn like this. It can be drawn like this. Your hypotenuse is always going to be the side directly across from the right angle. It's always going to be the longest side of your triangle. Okay, the second thing you're going to have to do is identify what angle you're looking from. So if you imagine that we're looking from this angle right here, that's our focus angle, and we're looking out from there. Being that this is our focus angle, the side adjacent is going to touch it. And it's going to be a leg of the triangle. Okay? So this is the leg that is adjacent to our angle. If you're looking for the side opposite, you're going to go ahead and take your angle that you're looking from, and you can go ahead and draw a line across. This would be the side opposite. Okay, it's across from the angle. And remember, you're always going to have a focus angle that you're looking from. All right, so we call this opposite side. We'll probably label it with an O. The adjacent side we'll usually label with an A. And the hypotenuse we'll usually label with H. Okay, now we know our vocabulary, and this picture is going to show up some more. We now have to look at some relationship. So if we're looking at our first triangle here, triangle ABC, we're going to look at ABC and we want to know which side is the hypotenuse. Well, the side that is the hypotenuse is this side right here. And we call that 5, or you could call it AC. Which side is adjacent? So we're looking from angle A. So the side that is adjacent to angle A is here. And we'll call it 3, or you could call it side AB. That's adjacent. Now opposite would be the one across. So that would be here. 4, or we could call it BC. This is the opposite side. Okay? Now we're going to look from angle B. So that was looking from angle A. Now we're going to look from angle B, and you'll notice things are a little bit different. The hypotenuse stays the same, but when it says what side is adjacent, well, the two sides that are adjacent, there are two sides that are adjacent because angle B is the right angle. So the side adjacent is AB, which equals 3, and BC, which equals 4. Okay? And the side opposite, well, this is the hypotenuse, because it is the right angle. All right, and then lastly, we're going to look at angle C. So now we're looking from this way. This would be the side that is adjacent. So BC, which equals 4, is adjacent. And then opposite would be across from this angle over here. This would be opposite, which is AB, which equals 3. And that we'll call O. And I can call this O. And I can call this A. And I did this one in a different color because this is the right angle, and we're going to talk about that. You don't necessarily use the right angle when we're doing trig. All right, so go ahead and try the same situation for, Now let's focus specifically on one of the acute angles, all right? And just because of this drawing, I'm going to go ahead and focus on angle C. All right? So I'm going to label my drawing. I know that this is my adjacent side because it's next to angle C, and this is opposite because it's across from angle C, and this is my hypotenuse over here because it's across from the right angle. So if I want to set up a ratio of the adjacent side to the hypotenuse, so I'm doing A over H. The ratio I would set up, remember a ratio is going to be written as a fraction. The ratio I'm going to be setting up is 4 over 5. Okay. The next one it says set up a ratio opposite side to the hypotenuse. So this time I'm going to be looking opposite over H, and that's going to be 3 over 5. And the last one says opposite to adjacent. So the opposite side over the adjacent side, which in this case would be 3 over 4. Okay, so you're going to go ahead and do this for the other two triangles, and then come back after you finish and check your answer. Something that looks like this, the hypotenuse is DF. For letter C, I just went ahead and wrote that particular angle is the right angle. All right, so that particular angle is a right angle, so we're not really going to have an adjacent or opposite side. Again, we'll talk about that later. And what you should notice is that depending on what angle you're looking at, the adjacent side will be opposite for each angle. Okay, so now we're going to move forward and we're going to set up our ratios. So it says you can look from any angle. Since I looked from angle F before, I'm going to go ahead and look from angle D, and I'm going to focus on this. So again, now my adjacent side is here, and my opposite side is here, and my hypotenuse always remains the same. So I'm going to set up a ratio of the adjacent side to the hypotenuse. So it would be A over H, which is going to equal 6 over 10. And you can simplify it if you want, or you can just leave it alone. All right, second, I'm going to do opposite over hypotenuse, which is going to equal 8 over 10. And lastly, I'm going to set up a ratio of the adjacent side, opposite side to adjacent side. So O over A, and that's going to equal 8 over 6. Okay, then we can do the same thing for GHI. The hypotenuse, of course, is 15. If you're looking at G, adjacent to G is 9. Opposite G is 12. Adjacent to H, well, this is the right angle, so I'm not going to do anything. And then it says adjacent to I would be 12. Opposite I would be 9. So you can see that they're opposite depending on what you're looking at. And if I'm going to set up my ratio of A over H, O over H, and O over A. So let's say I'll look from I this time. So that would be 9 over 15. This would be, this would be 12 over 15. This would be 9 over 15. And this would be 9 over 12. These special relationships have special names. And what we call this is SOHCAHTOA. The sine of A is opposite, adjacent. Looking at our ratios, we can see the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Again, it's going to depend on where you're looking. So if you're looking from the sine of A, you're going to focus on A. Sine is opposite and hypotenuse, so this is my opposite side, this is my hypotenuse, so this would be 8 over 10. If you're looking at tangent of A, tangent is going to be the opposite over the adjacent, so this would be 8 over 6. And the cosine of B, now I'm looking here, so this would now become my opposite side, this is now my adjacent side. So cosine is adjacent over hypotenuse, so this would be 8 over 10. And if you try these problems over here, cosine of A, remember the hypotenuse is always going to stay the same. So that if you're looking from A, this is opposite and adjacent. Cosine would be 6 over 10. The sine of B, this would be opposite and adjacent. So B would be opposite, which is also 6 over 10. And the tangent of B would be 6 over 8, opposite over adjacent. Go ahead and look at these problems here.